Okay, so today we're going to talk about the law of one price and what it means for us. So here I am, just in GeoGebra. I'm gonna go ahead and click Start Calculator, as we do. And the first thing we're gonna do is let's label our axes as we normally do. So let's come in here and say this is cash flow and time 0. Whoops, I made a mistake. What do we want? We want that to be cash flow and time 1. And then here we're going to have cash flow and time 0. Okay, so what we're talking about is the law of one price, and what that really means. Okay, so it sounds kind of confusing, but it's actually really simple. So what's happening? So normally, let's just do this. So normally what we do is we draw some vector like that, and then we have a line going through here, right? And so now this is our market. We can just do the 1-1 market. So this is putting money under your pillow. So what's happening here is we're going down 1, over 1, money under your pillow. So the law of one price, what it says is, I'll just tell you sort of the answer and then we'll work towards it. What it means is the function for today's price for any certain cash flow has to be a linear function, right? But not only does it have to be linear, its y-intercept has to be 0. So you'll notice that every one of these videos we've had our point at 0, 0, and then we've allowed ourselves to tinker with this and go up and down. But every time we've had this point at 0, 0. And not only that, but every time we've had a straight line. Rather than, it's conceivable that our pricing could be x squared or something, right? So a cash flow in time 1, let's say if we're going to get $2 tomorrow, we could think, well, let's just make it negative for sort of realistic sake. Okay, so let's say we're trying to get $2 tomorrow. It's conceivable that you'd need to pay $4 today, and that this function is nonlinear. And in particular, it's also conceivable that, let's make it negative again. It's also conceivable that we wouldn't have to cross this 0, 0 point, right? Your y-intercept could be something other than 0. But that's not how things are, and that is precisely what the law of one price says. It says it's got to be 0, 0, and it's got to be linear. Okay, so now that we've talked about what it is, I'm going to go ahead and delete this. I'm going to talk about why it is. So the reason why this is equivalent to the statement law of one price is because what it's saying is, incrementally, let's just zoom in here. If you incrementally go over just a tiny bit of cash flow tomorrow, so like getting, I don't know, what is this? This is like 10 cents tomorrow. That costs you 10 cents today if you're down here, right? But also, if you're over here, 10 cents today is the same as 10 cents, or 10 cents tomorrow costs you 10 cents today down here. So if you know any calculus or anything, all it's saying is your derivative is constant, right? So the price is the derivative, right? So the price of a payoff tomorrow is this slope, right? So in order to get one constant price for any amount of payoff, you need some function whose derivative doesn't change, aka it needs to be linear, right? Okay, so that's the first part. So that's why we know it needs to be linear. But that doesn't prove to us why it has to go through 0, 0. And the answer to that is there's always you could always just do nothing, right? So let's say theoretically, I don't even know if it's going to let me move this. Let's go ahead and draw a point here. And now, yeah, let's just go ahead and I'm going to kind of scrap this real quick. I'm going to scrap this. Okay. So now I'm going to draw a vector. Let's see if we can get this going from here to here. Okay. And now let's draw a line through it. Okay, so far we've decided that, okay, we understand that it needs to be linear, and that's because one price means it needs a constant derivative. Okay, but why does it need to go through zero? Because otherwise, you could always have the option of of just doing nothing. And so if this point was not at 0, 0, then let's say we wanted to get 10 cents of payoff tomorrow. Well, we're starting here at 0, 0. Now to get 10 cents tomorrow, we have to pay 20 cents today. Okay, so in this point of view, it costs 20 cents to get 10 cents tomorrow. Now all of a sudden, if we come over here, we're at 20, we go up to 30. Right now, that costs like, what does that cost? That costs like 5 cents or something. So we went from our price to being 20 cents to like 5 cents. So that's not a constant, right? The price is not constant. And that's because you always have the option of doing nothing. So this needs to be stuck at 0, 0, and this needs to be linear, aka it's a linear function with a y-intercept of 0, so it needs to be kind of, you can call it like, so it's basically just like a proportionality constant. Like the price tomorrow is proportional to the price today. You can kind of think of it like that.